You'll manage. I'll post it. Don't worry. Okay. Yes, so today we are going to do backwards chaining. So basically all the integrals we've done so far are really basic ones, like the antiderivative of x squared or antiderivative of cosine. So I want to just do a quick review of what happens when we do the derivative of something that has a composition. So like this first one, we get e to the 3x times 3. This one, this would actually be a natural log to the second power. So we would have 2 natural log of x times 1 over x, right? So chain rule. And how about the last one? We'll get negative sine of x squared times 2x. Okay, that means, let's say, for example, this last one here, if I were to take the antiderivative of this whole thing, I should get back cosine of x squared plus c. Okay. So it's not going to be just a composition of functions. It's usually going to be a composition, and then often it's times something. What is that something? That's the chain rule. Okay. So what that looks like, we call this U substitution. Whenever we integrate a function that's a composition, in order to integrate it, we have to have the derivative of that inside part in our integral.
And you haven't done substitution yet?
We're doing that now. So if I wanted to take the antiderivative of sine of x squared, I need to have 2x somewhere also in my integral, because I have to compensate for that when I work backwards. Okay, and then we get back the function. Also, we're only going to do everything on for today is plus c. So we're not going to do limits of integration until next week. Okay, so the first part of U substitution, we have to be able to identify what part is U. So if I have an integral of sine of 2x dx, what do you think U would be equal to? 2x. If I have 1 over 2x minus 1, what do we think that U would be equal to? 2x minus 1. What if it's an e to the 4x? 4x. So what is e? It's the exponent. Here, the inside is 3x plus 5. Here, cosine theta. And lastly, 3t minus 1.
Why is U for the second class one cosine? Because there's also a sine.
Okay, so the one that has the exponent is usually the U. Now, there are some exceptions. And what we're basically looking for, if I did the derivative of cosine, that would give me negative sine. Now, I don't have a negative. You'll see how we deal with negatives and positives, but this sine doesn't have an exponent, does it? And I won't give you ones where both of them have exponents. With sine and cosine. Okay, I'm going to break down the steps, and then we're going to just do lots of examples, because that's really just practicing. Okay? All right, so first thing, here's our example. We have 4 times 4x minus 5 to the 6 dx. So we're going to let U equal 4x minus 5. Okay. So down here, if we make U equal to 4x minus 5, what is du dx? Just 4. Right. So we're going to be, when we work with integrals, we work with what are called differentials, meaning just the dx. So I want to isolate, if this is du dx, I want to isolate du. So I'm going to have 4, And if I multiply both sides by dx, du is equal to 4dx. Okay with that? All right. Next step, we're going to rearrange. This is actually an optional step. I'll show you. But we want to rewrite the integral in terms of u. We don't have to rearrange, but I'm going to show you 4 dx. If I put the 4, I'm just going to rearrange that first step. So I'm going to write 4x minus 5 to the 6 and move the 4 next to the dx. This is what I was saying is the optional step. Okay, now I want to get rid of all the stuff with x, and I want to simplify this to make this an easy function that we can integrate. Well, 4x minus 5 is u. So I can make that u to the 6. And what happens with the 4 dx? I'm going to replace that with du. Question. Where did the 4 go? So 4 times dx is the same thing as du. So I just replaced the 4 dx with du. Good? Okay. Now, I purposely set it up this way. Sometimes I have this line here that says you might have to compensate for coefficients. What if we didn't get a 4 here? What if we got a 2? Okay, and I'll show you how we'll deal with that. But I purposely gave you one that had the 4 in it. But now it's easy to integrate. Integrate with respect to u. What's that going to be? U to the 7th over 7 plus c. Okay. Substitute the original variable back in. That was 4x minus 5 to the 7th over 7 plus c. Now, what's that? Is it now?
I mean, you're taking
It's kind of. Yeah. I mean, it follows the same kind of rules. And there is going to be a shortcut. I'm not going to show you the shortcut today. But that's because it doesn't always work. Okay? So I want to make sure you know how to do. Yeah. But this is almost like power rule, but we got rid of the 4. Yeah. So the coefficient. Now, how can you check your answer? You could do the derivative of that, right? 7 moves to the front. 4x minus 5 to the 6 times 4. The 7s would cancel.
Wait, how do we know C is 4? Oh, times 4.
Times 4 for change. Okay. Let's try the next one. Okay, we're going to let u equal to what? X minus 7. So this implies du, okay, du dx, the derivative of x minus 7 would just be 1. So it's going to be 1 dx, or just du is equal to dx. Okay. All right, next step. I'm going to rewrite this with just u to get rid of all the x's. So it's the integral x minus 7 is u to the 3rd. I'm replacing dx with du. This one would work out easily with just thinking of the power rule. Well, x minus 7 is all equal to u. So I'm taking the x minus 7 and I'm just putting u in its place. Okay. After a few examples, it will get less confusing. I promise. Okay, this will be u to the 4th over 4 plus c. What do we want to do? We want to go back, plug back in the original. So that's x minus 7 to the 4th over 4 plus c. This one, technically you could do with a shortcut. Let's see. The shortcut, as long as if the derivative of the inside is 1, then it will always work out really nicely. But if the derivative of the inside is not 1,
add 1 to the.
Yeah. But again, that worked out nicely because the derivative of the inside was 1. So when du is equal to dx, so the next one it won't. Okay,
Is it
so
just
that's
when
where I
equals-
said
Wait, how do
there.
you know again?
We're not going to do the shortcut. We're just going to.
Is it just when equals one?
No, it's when the derivative of the inside is a constant. But again, don't worry about that. This won't work. You got to do this one by writing it all out. So what do you? Yeah, what do we want to make u equal
X squared
to?
plus one.
X squared plus 1. Okay. What is du equal to? Derivative of x squared is 2x and then dx. All right. How convenient. You have a 2x and a dx in your integrand. So I'm going to use these two combined will be du. Now, you could rearrange it, but you don't need to rewrite it like I did on the first example. Right? We're just taking these two parts, 2x dx, and replacing it with du. What's the integrand? Square root of u. Remember, our goal is to always, these have to be the same variable in order for us to integrate. Otherwise, we wouldn't be able to do anything. Okay, so that's u to the 1/2. That'll be u to the 3/2 over 3/2. So 2/3 u to the 3/2. Plug back in. X squared plus 1. Oh, that's it, 2/3. Questions? Good so far? Okay. Now the next 2 pages are just more examples. Okay. Let's see. What are we going to let u equal to here? X squared plus 9. So du is 2x dx. Now, I purposely made these problems work out nicely. We'll gradually get into some that are going to be a little different. Right. Again, I got that 2x and that dx can be replaced with du. So I have the integral from, or integral of u to the 5th du. Good. U to the 6 over 6. Let's see. Plug back in the original. Okay. Good. Again, how can we check our answers? Do the derivative of this. We should get back what we started with. Okay, now we have an integral of sine x e to the cosine x. Cosine x. We're gonna, if we have an exponent, that's what we're gonna work with. Okay, this implies derivative of cosine, negative sign.
However, we don't.
We don't have a negative sign.
Well, we can
Negative du. Okay, so how convenient. I gave you a sign. And in fact, you wouldn't be able to integrate this. You can't integrate that anyway, at least not this year. But with the methods that we do for AB. There are other methods. Using integration by parts is one, but that's not something you do until talk 2. No, you don't do integration. That's BC.
Can you put the negative on the outside?
So we're going to put the negative outside. And this will be e to the u du. So the sine x and the dx were replaced with du. That negative, I just treat that like a -1 coefficient. So just move that to the front.
So is it whatever minus c as well? So
No, not minus c, still plus c. Yeah. So this will just be negative e to the u plus c. So negative e to the cosine x plus c. Yeah, in fact, you don't have to, like, if there's a coefficient, if you made it minus c, that's, like, it doesn't, like, you're not necessarily having to distribute.
Because I was just thinking since you.
But we don't know what c is, so you're right. Technically, you could put a minus c and distribute, but yeah, just leave it. Okay, next one. What are we going to let u equal? 5 plus 2x cubed.
Do we have to write let you or can I just write
You can just write u. When I introduce a new variable, I like to write that u, but you just write u. Okay, what is du equal to? 6x squared. Okay. So in the last problem, I had to get rid of the negative. In this case, I have to compensate for the 6. So I'm going to replace 160u with x squared dx. Yeah. Okay, because I don't have a 6. So when I'm missing a coefficient, again, I purposely set them up previously so that coefficient always went away. But that's not always going to be the case. So in order to compensate for that missing 6, I have to multiply by 1/6, the reciprocal. Right?
I still like
Oh yeah, you can do du over 6.
You can't just use the 6x squared and then just do 6 as a coefficient inside of the integral.
Yeah, it's pretty
I don't know.
No, you want, because you want to make it equivalent. You don't want to leave the 6 in here, and, like when I write it with u.
Can you just like, because the multiplication thing changes to 6 the outside of the integral or the
Where do you want to
whether
move
or
the
not
6
you do it
to?
inside of the outside of the inside.
He's treating the integral as a parentheses.
Okay,
No. Yeah.
listen, the 1/6, like the coefficient, it doesn't matter where you put it. It doesn't matter. I just like to put it in the front, but by all means, make it du over 6. I just automatically, especially when we get to the next lesson where we actually have to start plugging in values, it's so much easier to just plug into square root of u and then deal with the 1/6 later. Does that make sense? So I always just, I automatically move the coefficients to the front. We should end up with the same answer. So what do we get for here? So u to the 3/2 over 3/2. So times 2/3. So our coefficient is 1/9. Thank you. And then we have 5 plus 2x cubed to the 3/2 plus c. I'll save it. You want to try the next one on your own? We got this. You do.
Oh, I just did this one.
Okay. When you do the derivative, do you get back what you started with?
Yeah, you do.
You do too.
Dang.
Oh.
You got it? Nope.
That was fast now. Are you sure?
I'm sure.
Yeah,
Yeah, you're.
How?
What'd you get in the denominator?
Just aim on that.
What's your denominator?
I'm gonna say new head.
What? Wait, so I won? No.
No.
I decided I'm right.
You decided you're right?
Is it? Don't tell me. In the denominator?
On my roll.
It should be over 4.
Okay, I have a missing 4. What's the derivative of 4x plus 3? 4. So du is equal to 4 dx. But I don't have a 4 anywhere in my integram. So I have to compensate for that missing 4 by multiplying the integral by 1/4. So I'm going to replace this with 1/4 u to the 4th du.
Is u to the 5 over 9?
20.
Oh, 20.
That would be better.
That'll be adding.
So that would be correct. Right? So I have 1/20th 4x plus 3 to the 5th plus c. You can also make it over 20. I don't really care.
Wait. Then how for this one? Is it just 1?
Okay. I had mentioned the shortcut, if the derivative of the inside is 1, then the shortcut works. Now there is another shortcut, but I don't want to confuse you with 2 1.
Well, I feel like if I just know all the shortcuts, I can figure it out.
Yeah, but the shortcut won't work on the next one. This shortcut doesn't work here.
This one looks scary anyway. So.
That's why I'm trying to show you this one way.
Yeah, I just need to write that.
I'm just going to show you this because there are times that the shortcut doesn't work. So you still need to know the whole process. Yeah, there are times that you need to know it. Okay. Natural log of x to the 6 all over x. What do you think we're going to make u equal to? Natural log of x. Are we good now on that one?
How do you know that? Because the 6 acts as exponent.
Because when the 6 is written this way, it's really natural log of x all to the 6th power. So also I'll give you a hint. If you see something with a logarithm and there's an x in the denominator, you're going to make the logarithm u. Because what happens when I take the derivative?
1 over x.
Good. So I get 1 over x dx, which is what I have here. Okay, so when we do rewriting this, it becomes just u to the 6 du.
He actually did.
Okay, did we get it? Do you understand how I turned everything into just u? No. Okay, do you understand when I do the derivative, I get 1 over x times dx?
Yeah.
So that is all replaced with du. So now the natural log to the 6.
Oh yeah.
There you go. So then we just get u to the 7th over 7 plus c. So natural log. Yeah, that's fine. Okay. All right. 3 more. And then we have homework. The other class finished almost all of it. So
Wait. H dub.
Let me ask you this.
they finished.
Miss Casey.
I didn't know what you said at first. H dub.
Wait, is the answer? Are they answering?
They will be. They're not at the moment. Okay. What's u equal to here? X squared plus 3. So du 2x dx. Now, I have an x and a dx. I don't have a 2.
Oh, 1/2.
So I'm going to multiply by a half. Okay. Now, I need to write the rest of it in terms of u. So that's going to be 1 over root u. Or, to integrate it easily, u to the negative 1/2.
Oh.
Because this would all be in the denominator, so, okay. Now power rule. So that will be u to the 1/2 over 1/2. Conveniently cancels out that 1/2, or multiply by the reciprocal, make it 2. So our answer, square root x squared plus 3 plus c.
You just call it
Here.
This next one
quits.
doesn't look
That
very
makes
fun.
it sound bad.
Oh no, it's easy. I promise. Come on, these next two are easy. Okay, what do you want to make u equal to here? X cubed plus x. What do we get for du?
Oh my god, 3x plus 1 here.
How convenient. 3x squared plus 1.
Because that's what's
That's the one that has an exponent. This one, now, listen, if you really wanted, you could FOIL and then multiply all that together and then just do power rule. But this is actually easier to do.
Can we do shortcuts?
Okay, stop with the shortcut.
But it worked.
Okay, so this just becomes u squared du, right? Because all this stuff went away and was replaced with du. So it just becomes u to the 3rd over 3. So x cubed plus x to the 3rd over 3 plus c. Last one. Okay.
I think we should do this one on our own.
You want to try that one on your own? Go for it. You could do that while I'm passing out the worksheets.
Quite long.
Lily, what did you do? I don't get what you did.
What else can you do?
They can put it.
Okay.
Oh, wait, there's
Oh,
three.
yeah. Hold on, I have more worksheets. Okay, hold on. Yeah, what did you make u equal to?
3x.
So du is 3 dx. So I'm going to multiply by 1/3.
Wait, why not 1/2?
Okay, so I'm going to take this 2 and also move that to the front just so I don't have to deal with it. So, to 2/3.
I didn't know that was
Coefficients can always be moved out front. I promise, it's the best approach to always just take those coefficients and move them. It's going to make it much easier.
Yeah,
Wait, we're on this one?
now
Wait, do you understand? Well, this was used
I don't get like why we changed the DU.
because we have to. If we change this to u, this has to be to u.
No, like we say let u equals 3x plus 1 and
Uh-huh.
then we write du equals 3 dx.
Yeah.
But why do we do 1/3 du?
Because there's no 3 here out of 2. So I'm going to replace the dx with the 1/3 du. Okay, let me just finish this one up. U to the -1 over -1. So this will be -2/3. Well, let me actually write it this way. So it's going to be negative 2 over 3 times 3 plus 1
Yeah.
plus c.